Check, because that acted different. All right, so what are we on, 7 or 8? 8. 8-2, Pythagorean theorem. Does that sound accurate to everyone? Good. What numbers did we do? 10 through 34 evens. Maybe that's an email telling me that I'm live. If it is, then I'm not going to waste my time checking. There he is. Pythagorean theorem and its converse. Number 10 is 12. Number 12 is 33 times the square root of 3, which is approximately equal to 57.2. 14 is 4 times the square root of 3, all over 9, which is approximately equal to 0.8. 16 is 50. 18 is 30. 20 is about 2 miles. 22 is no, because 23 is not greater than 10 plus 12. 24 is no, because 91 is not greater than, whatever it is, 44 plus 46. 26 is yes, and it is obtuse, because 196 is greater than 16 plus 144. 28 is 17. You know, this is what I'm afraid of whenever what you call it is here, and I'm not. Stuff gets all messed up. True facts. Where are we at? Number 30. 30 is a right triangle. Measure of xy is square root of 8, measure of yz is square root of 2, and measure of xz equals the square root of 10. Number 32 is obtuse. Measure of xy is 5, the measure of yz is 2, and the measure of xz is the square root of 41. And the square root of 41 squared is greater than 5 squared is plus 2 squared, all the things. Yeah? Where do we go through 34? 34 is 0.3 miles. What questions do we have on that lesson? Number 14. Before I do that, let me make sure Ember Learning Labs is live. Look at that. Whoever Big Homie is, hi to you too. I don't know why my live chat thing isn't popped up. I'll pop that up. What did you say, 14? Yeah. Okay. Oof. Oh, that's the wrong me, bro. 14 is this right triangle. Yeah. See? One grows tired of people. Not just yelling at them, just people. It's okay, Reese. I won't hit you on purpose today. And we've got 4/9 over here. X right there. 8/9 over here. And we are expected to find X. So, what should we do? What is this? This is not the right me. Come on, thing. 8/9 squared. Great job. What did you? That's what I heard you say, but you kind of were mumbling and yelling at the same time. So. I was saying 4/9 squared. 4/9 squared plus. B squared equals 8/9 squared. Plus what? X squared. Why are you saying Z? X squared equals 8/9 squared. What's the problem here? Why can't we do this one? Y'all know how to do this. Just need to do 8/9 squared. What's 4/9 squared? 16 over 81. How do we square fractions? Square, multiply times itself is square the top, square the bottom. plus x squared equals, what's 8/9 squared? 64. 81ths or 81st, I don't know, whatever that word would be. All right, now what?
Subtract the 16 over 81.
Subtract the 16 over 81. I think I'm gonna have to throw this marker away because this one was also open, which is partially my fault because I guess I forgot to hide my colored markers like I usually do because stupid children. Oh, everything's trash. X squared equals what? 48 over 81. Now what do we do? Divide both sides by 3?
Wait, no, never mind.
What? I'm confused.
Square root both sides.
Square root both sides makes a lot of sense. That button. Yes, sir, you do. So we're at top and bottom. So we end up with x equals plus or minus, because when we take both sides, square root of both sides, we get plus or minus. We're going to throw out the negative because we're talking about distance. But I don't want to leave our brain. Yeah, what's the square root of 48? Some stupid number, right?
Yeah.
Is there any perfect squares that go into 48?
6.
6 isn't a perfect square. 4 is a bigger one.
9.
Does 9 go into 48? Okay. It's not that. 8 isn't a perfect square. 16 is a perfect square. Does it go into 48? 16 times what equals 48?
Oh, wait. I thought you were talking about 16 times what number we're pulling out, but you're talking about, okay.
16 times 3. So this will turn into the square root of 16 times the square root of 3 all over 9, right? So that would equal, we're throwing out the negative one, right? So that would equal 4 times the square root of 3 over 9. Can that be reduced any? What? It cannot, which means that is our answer. Easy peasy, lemon squeezy. What other questions?
I did this problem totally
Yeah,
wrong.
16 over 81. I don't know who you are, but yes. You did this problem totally wrong and what?
I still got it.
Did you? What did you do totally wrong?
I don't even know.
You don't even know, TBH. Question 10. You know it's the easiest one, but something that you said that I couldn't understand. I don't know. Number 10. Maybe there's something called streaming. Yeah. I know about streaming delay. Thank you, big homie, whoever you are. I've done lots and lots of live streams. But yeah, you're welcome to answer. I don't know whether you're one of my students. Your username makes me think you're probably not. But also try to understand the lesson. Yeah, good. Understand the lesson, whoever you are. Where are you from? Number 10. Why do you need, you do not need help with number 20. What is your actual question with number 10? Do you have a real question? Because we've been doing basic Pythagorean theorem all year. Do you have a question or did you just not do the work?
I did the work,
What do you think you did wrong?
the answer I got was 9.
Okay, so did you do 9 squared plus x squared equals 15 squared, or did you accidentally do 9 squared plus 15 squared equals x squared?
No, I did 9 squared plus b squared equals 15 squared.
Plus, I don't know why you're putting b when it's an x, but that's totally, that won't mess up your problem. Squared equals 13, yeah, 15 squared. So 9 squared is 81, right? plus x squared equals 225, right? Subtract 81. X squared equals 225 minus 81 is what? 144. Square root of 144 is 12. Did you figure out what you did wrong? Good. Was it a small thing? Okay, good.
Could we do
18.
18?
Yeah.
I got 60 and I don't
Y'all need to check your own problems. If it's just like a small mistake, actually look at it before you ask. Have you done that yet? Because there's no sense in like just doing it just because you missed it if you haven't even looked at it.
What did you say the answer to 16 was?
30. 72. 78. So what would you do?
Answer to 16 was
This is 8. Oh, you said 16 or 18?
16.
16 is 50.
Oh, okay.
Is it, what did you ask for? 18. Yeah, 18. So what would you do?
see if it could go down to 100.
No, you're just going to do the Pythagorean theorem.
Oh,
X squared plus 72 squared equals 78 squared. Solve, right? Yeah. You were trying to figure out whether it was a Pythagorean triple and do some reduction and all that kind of stuff. You can't really know that yet
Well,
until...
It says use with that Pythagorean triple find x.
Oh, it does?
Yeah.
Oh, okay. So you had to... So if you're doing that, you just try to reduce it down to whatever it is. Keep on dividing both of those numbers until it matches one of those top Pythagorean triples. You could also do Pythagorean theorem. They're trying to get you to see Pythagorean triples, which this makes sense that this is a Pythagorean triple because, I mean, you could guess it and you could try it, right? If you didn't have those instructions, that would be one way to solve it. Or you could just use the Pythagorean theorem, right? Either one. Any other questions from this lesson? Okay, let's do the next one, special right triangles. What numbers did we do? 8 through 32 evens. United Arab Emirates. How do you spell that? How do you pronounce that word? Emirates. Emirates. I think so. Oh, I feel like it's probably like 9 o'clock at night over there. I don't know whether you're still there. What time is it over there? Are you doing this in the evening? Are you doing this for fun? Or you have this as your class? Number 8 is 8 times the square root of 2. 10 is 34. 12 is 19.5 times the square root of 2. Excuse me. 14 is 9 times the square root of 2 over 2. 16 is 6 times the square root of 2 or 8.5 centimeters. 7:30, yeah, see, I thought it was the evening. 9 times the square root of 2 over 2. 16 is 6 times the square root of 2 or 8.5 centimeters. 18 is, x is 8, y is 16. 20, x equals 15 times the square root of 3 over 2 and y equals 15 halves. 22 is 24 times the square root of 3 and y is 48. 24 is 12 times the square root of 3 or 20.8 feet. Excuse me. 26 is no, and you'd say something like the height of the box is only 7 centimeters and the height of the highlighter is about 7.8 centimeters, so it will not fit. Number 28, x is 13 times the square root of 2 over 2, and y is 45. 30 is, x is 3 and y is 1. And 32 is 6 times the square root of 3 and y is 3. And I don't know if we did it, but 34 is 6 inches and 12 inches. What questions do we have on this lesson? We can do 30. Sounds great. I'm glad you're getting something out of it. That's great. Number 30. Okay, we got a couple of 30, 60, 90 triangles. X is here and Y is there. This one's 60 degrees over here. This one is 30 degrees. This one up here is 2 times the square root of 3. And we're supposed to find X and Y. What kind of triangles do we have here?
Right triangles.
That's true. They're special right triangles. Which of the special right triangles is this one?
30, 60.
It's a 30, 60, 90 triangle. What are the ratios of all 30, 60, 90 triangles? 1, 2, and square root of 3. Right? So, let's do a couple different colors, right? So, in this triangle, this is a 30, 60, 90. This is also a 30, well, actually, yeah. So, this is a 30, 60, 90. This is a 30, 60, 90. That's also a 30, 60, 90 triangle. There's all kinds of 30, 60, 90 triangles. So, in this kind of medium-sized triangle, this would be 1, 2, square root of 3, right? In the little bitty triangle, this would be 1 and 2 and square root of 3. And then in the great big triangle, it would be 1, 2, square root of 3. So we've got all kinds of ways to get to where we want to go. So do you want to start with X first, or do you want to start with Y first? Really, there's only one option, actually.
Why? Oh, yeah.
We can't really start with Y first.
Yeah, with the way you wrote it, it looks like you could and get it right still.
Right, because the colorful numbers make it confusing. Yes, I agree. We only have the black stuff. The colored stuff is just the ratios, right? So we can't get to Y. We really can only get to X using this triangle. So let's take this triangle and pop it out of the problem and see what's going on. So we've got this triangle right here. It's a 30, 60, 90 triangle, right? And this side of this medium size that's colored in brown, keep our colors to match, has got an X here, has got a 2 times the square root of 3 here, and this is 30 degrees, right? So, the side that we know something about is 2 times the square root of 3, right? This, on our ratio, this is the 1 side, right? This is the 2 side, and this is the square root of 3 side, right? So we know the 2 side. The trick with these, and the best plan, generally speaking, almost always, is to try to, whatever you're given, get back to the 1 side. Because if you have the 1 side, then you just multiply times 2 or square root of 3 to get the other one, right? So if we have the 2 times the 1, then this, how do we get back to the 1 from this one? Divide it by 2. So 2 times the square root of 3 divided by 2 is what? Square root of 3. So this side we can tell is square root of 3. Because 2 times the square root of 3 divided by 2 equals square root of 3, right? Does it make sense, or are we nodding so we move on and don't fall asleep? Make sure it makes sense. If it doesn't make sense, what should you be doing? I know at this point it's almost March, and so our brains are starting to ooze out of our ears. If you are confused, what should you be doing? Asking questions, not taking a nap.
Why do you put it over 2?
Because we know the ratio on this triangle is 1, 2, square root of 3. And we know the 2 side. We're trying to get back to the 1 side. How do we turn a 2 into 1 by either multiplication or division? How do we turn a 2 into a 1? Divide it by 2, right? So to get back to the 1 side, we divide it by 2. So now we've got this side. So now that we've got the 1 side, how do we get to the square root of 3 side? Multiply. So square root of 3 times square root of 3, which is the same as square root of 3 squared, right? So what's square root of 3 squared? 3. So this side, so x equals 3. First part of our answer, x equals 3. Okay, so now we know that this side is 3. That's where we are on that bit, yeah? So now we got to somehow get to y. Let me erase some of the mess up at the top. See if we can puzzle out what's happening. We know, because we know something else from this big picture now that we've labeled on our little one that we pulled out.
We know that one side is the square root of 3.
That one side, I'll take that. The altitude, right? Yeah. This little altitude right here is the square root of 3, right?
Just means it's really easy for us and why.
That's true. Let me pull it out and explain even more, just to make sure we're understanding. So pulling this little mini triangle, right? This little mini one out. Right now we know that this is 60 degrees. This is the square root of 3. And we're looking for y. This side on this 30, 60, 90 triangle is the square root of 3 side, and it equals square root of 3. So that means y is equal to the square root of 3 divided by the square root of 3. What is the square root of 3 divided by the square root of 3? 1. So y equals 1. Does that make sense? I expect more questions from this lesson than the other lesson. So if you're a little confused, make sure you ask them. This is kind of brand new stuff. This is really, in a way, the other geometry lessons that we've had in the past are kind of brand new stuff. We get theorems and doing proofs and all of that stuff. But it's all almost like logic, common sense, right? Like, okay, this is obviously equal because it looks like it is. I know I'm saying opposite of the way we do things in here. If it doesn't say it, you can't like assume it, right? Which is true. But the other stuff kind of like makes sense. This is like brand spanking new. Like this is brand new, brand new. And the better you get this right now, and we haven't really even started doing trig yet, not really. But the more you get this now, the easier it's going to be in pre-cal or physics or whatever else later. So. 20. Sounds grand. Sure. $20. I promise I'm not drunk, just tripping over chords. Okay, this is 30 degrees, this is 15, and y, and x. What kind of triangle is this? 30, 60, 90, right? Same schmogoigle, right? 30 degrees, 1, 2, square root of 3, right? It's our ratio. So which of those sides do we know? Do we know the 1 side, the 2 side, or the square root of 3 side? The 2 side. So this up here is a 2 side. So to get from the 2 side to the 1 side, what do? Divide by 2. So y equals 15 divided by 2. Can we reduce that number? That's not reduced. That's true. We don't care about that. Fractions are great. We love fractions. Fractionsofthebomb.com. Fractions are great. Decimals are annoying. Can we reduce that? Can we reduce that number? No. Great. Circle it. To get from the 1 side to the square root of 3 side, we take that and multiply it times the square root of 3. Done. Does that make sense? Any questions on that problem? Any other questions?
I did have a question from the previous assignment.
Okay, a question from the previous assignment. What question is that?
The first question, 30.
Question 30. What about it?
It's just graphing it.
Which part are you having a hard time with? The graphing it or the solving it? The what? Which puzzle pieces are you stuck on? Or did you try it? Like, I don't want to say I didn't try it because then you might not do it. I see the smirk. I see it. How would you go about solving that problem? Just to be clear, because I showed this wasn't just in this class. Yeah, if you get the decimal equivalent, yes. Just to be clear, your homework should never have a problem on it that says, I don't understand how to do this problem. That's a waste of your time and my time. Try what you think you do. Engage with it with your brain. Don't look at it and be like, oh my gosh, I'm afraid. There's nothing in this class where you should be doing that, ever. Because here's the deal, boys and girls. Every single one of you knows how to plot points. So like on number 30, you should at least have a little graph with some points on it. Yeah? Yes, I will do it because we have time today. Does anybody have any other questions? You shouldn't ever be like, oh my gosh, I'm scared, I'm just going to ask about it in class. That's a waste of your time. Don't do that. And also, don't wait till 11:50 and start your homework and then try to do it and be like, oh my gosh, I don't have time, I'm going to ask about it in class. Don't do it, especially not on a Tuesday.
If I get it done, I'm not always going to get it done before 11:59, because I get off work at 11.
Okay. You don't want to go down this path with me, but you ready? You ready? Here you go. You went there, I'm going to go there. You had to do this work. You had from 10 o'clock on Thursday, 10 a.m. until 11:59 p.m. last night. You had Thursday, Friday, Saturday, Sunday, Monday. If you wait till Monday, of course you might not make it because you work and you have other school. I know y'all don't just do math.
My question is, if I do get it submitted by 1 o'clock, is it still late?
Definitely late, points off. That's a silly question. That's why I didn't answer it the first time you asked. You knew the answer already. You were just hoping that the answer was different than what you wanted. Okay, number 30. Sounds great. Let's do it. We've got a problem right here, number 30, and it's a triangle that is x, -3, -2, y, -1, 0, and z, or z if you prefer, 0, -1. Speaking of Zed, where's Gina today, I wonder? Isn't Tuesday the day she's normally here? We're missing like 5,000 people. So we don't really have to graph it, but it might be useful to get us a little graph. So let's do that real quick. All right. Y'all all know how to do this without any trouble, right? We're going to put a point at -1, 2, 3, -1, 2, so right here. And then one at -1, 0, so right there. And then at 0, -1, so right here. So we have this little triangle. So the way they want us to solve this problem on this lesson, because of what's covered, is to figure out the distances and then do the Pythagorean theorem and use that method. So that is one method we could use to solve this problem. There's other ways to solve this problem. So what do y'all want to do? What could we're trying to figure out whether, well, I say that. If it's one of the solutions, then there are other ways. If it's either acute or it's obtuse, then that's really the only way we can really prove it, it's with that method. But so what we're trying to do, what the instructions say to do, is say whether this triangle is acute, obtuse, or right. Correct? So what were you given in the lesson to figure out how to determine if a triangle is acute, obtuse, or right?
If a squared plus b squared is greater than c squared, then it is
I don't know what I'm writing.
acute. If a squared plus b squared is less than c squared, it is obtuse. And if a squared plus b squared equals c squared, it is right.
All that is accurate. Which is what they're going to want you to do to solve this problem. You could also, if you want to try for a shortcut, you could look at it and be like, okay, I think those are right. And if they are right, what could you do to prove that they were right? We've done this quite a few times. We could look at their slopes and figure out if they're opposite reciprocal. That's absolutely true. So, where do we want to start?
Reciprocal slopes.
Okay, let's say I should label these. This is X, this is Y, and this is Z. So you're looking at that and you'd be like, I think that's a right triangle. So we could find the slope between XY and the slope between YZ, right? Because that looks like a right angle, so use a different method to prove it. We may do this twice. We may do this way and then the way that you're supposed to do it on this lesson, just to find. What is the slope formula?
Y equals mx plus b.
That's the slope-intercept form of a line, which is great, but not quite where we're looking.
Minus y2 over x1 minus x2.
Usually for consistency, we write y2 minus y1 or x2 minus x1, but both are correct. Either one works. Either one is totally fine. The reason why we do it this way is because we almost always, it doesn't really matter when we're talking about distance, because distance is, we take the absolute value. But when we're doing some physics problem or something, we're looking at displacement, then the sign matters. And so usually we do final minus initial is the way it's written. So that's the reason why it's typically this way. But it doesn't matter, like, as long as they're the same thing. As a long-winded explanation to say you're right, and this is why this is how we typically do it, but it doesn't actually matter. So the slope between x, y minus. What's going to go right here? Negative 3 is the next, so definitely not. Negative 2. Like, I am doing y1. Dang it. Can't make me change. What are we going to put right here?
0.
What are we going to put right here?
Negative 3.
Negative 3. And what are we going to put right here? Negative 1. What's negative 2 minus 0? Negative 2. Ka-chink, ka-chink. Negative 3 plus 1 is negative 2. So the slope between x and y is positive 1. So the slope between yz equals what's going to go right here? Negative 1. What's going to go right here? 0. Now you're just doing it to be crazy now. What's going to go right here? 0. Negative 1. Ka-chink, ka-chink. What is negative 1 minus 0? Negative 1. 0 plus 1? 1. So this is a little bit tricksy. Is 1 the opposite reciprocal of negative 1? Yes, it is. So this is a right triangle. What formula would you have to do it the way that they wanted you to do it in this homework assignment?
Find the distance.
Yeah. So yes, the distance formula, right? So what's the distance formula?
Square root of x1 minus x2 squared plus y1 minus y2 squared.
And again, we usually do that the other way around, but it doesn't matter. Yeah, so you'd shove stuff into there, and then you'd shove those into this formula and compare it, and it would be this way. This particular, especially in like Algebra 2, there are some lessons where in order to get credit for a problem, you have to do it the right way because the point is the method. In geometry, that's almost never the case, right? Because in geometry, you're supposed to be using logic and all the tools that you have available to you. So you don't necessarily have to always do it the right way. There isn't really a right way in geometry, right? So use whatever tools you have available to you. Now, if you were to if this problem was on a test, and you just wrote the word right and didn't do anything else on the page, I'd probably count points off. Because the point is definitely not to just guess the right answer. That doesn't make any sense and isn't helpful. This isn't guess class. This is geometry, which is proper Euclidean geometry, which is to say it's like classical logic wrapped in math. Or the other way around, maybe. What other questions? Any other questions?
Can we do 10 on 8-3?
Sure. 8-3, number 10. Oh yeah, that's good. Get the other one right other one special right triangle. Okay. We've got a triangle that looks more or less like this one. And it's labeled as x and 17 times the square root of 2. And we're supposed to find x. What kind of special right triangle is this? 45, 45, 90, right? What are what's the ratio on a 45, 45, 90? 1, 1, square root of 2. Do we know one of the 1 sides or one of the 2 sides? The 1 side. So to get from the 1 side to the square root of 2 side, what do we have to do? Yeah, so this would be 17 times the square root of 2, that's this one, times the square root of 2. What do we do with that? It is 17 times 2 because square root of 2 times the square root of 2 is the square root of 2 squared. Square and square cancel out. So this turns into 17 times 2. So x equals 34. What other questions do we have, kids? 16. What is the length of the hypotenuse of 45, 45, 90 triangle? Is it a vocabulary question or a you made a mistake question? Okay, so what vocabulary, what words are we not getting here? Okay, so do you know what a hypotenuse is? Yes, you do. What is the hypotenuse of a triangle? Of a right triangle? Yeah. Yeah, it's the longest one. So what do the legs have to be? The other ones. And it's 45, 45, 90, so it's isosceles, so both of the legs are the same, right? So that's what's happening there. So it says as the leg length is 6 centimeters, right? And it wants to know what the hypotenuse is. So how do we find the hypotenuse? 6 times the square root of 2. So it would equal 6 times the square root of 2 centimeters, which is approximately equal to, which this being a word problem, it wouldn't be terrible to punch that in the calculator because of the fact that it has centimeters on it. I mean, we're probably almost certainly going to use this number in some sort of like real world application at some point. So getting a decimal equivalent in a problem like this that has units wouldn't be terrible. At this phase of things, I probably wouldn't count off with either one of these answers. Either one of those would be fine. Any other questions? 8 was 8 times the square root of 2. Do you understand how I got there? Okay, good. Because you'd have to rationalize the denominator and all that stuff. And then it reduces. Did you get 16 times the square root of 2 over 2? Yeah. Yeah, and then it just needs to reduce.
How do you get 16 times square root of 2 over 2?
So to get from that 16, to get from the 16 to x, you divide 16 by the square root of 2, right? We don't like square roots in the denominator, so you rationalize it. Multiply times the square root of 2 over to the square root of 2. This one, that cancels. So you've got 16 times the square root of 2 over 2, but then that reduces. Does that make sense? Good. Good, good, good. Any other questions? All right, I'm gonna let y'all go early so I can grade papers. I'll see y'all on Thursday when we really actually start trig for real this time. You get to learn SOHCAHTOA. It's really easy. What we're doing in this lesson is like super easy. Don't get scared and run away. It's really like one of the easier things you've done all year. There's no proofs involved at all. We could do proofs, but it doesn't have proofs. We save the trig proofs for pre-cal. Goodbye. Oh, you changed your name. I don't know how to pronounce your name. I would pronounce it Saif Sawad, but that's probably not remotely right. I apologize for my butchery.